Good day guys, and welcome to this video. In today's video we are going to be providing a solution to these questions we have before us here, and these questions are under a topic known as binary operation. And for the past 1 month now, we've been discussing about number-based operation. So we want to test our knowledge of what we've been learning so far about binary or number-based operation. Now for question 1, we are asked that if 2n4 in base 7 is equal to 15n in base 7, in base 9 rather, we are asked to find the value of n. Now you notice that that question 1 is an equation. Is that true? And if it is an equation, it means whatever is on the left hand side must be equal with that on the right hand side. Let's have solution 1. So for question 1, we are told from the question that 2n4, this number is in base 7, is equal to 15n in base 9. We are asked to find the value of n from the question, that is this capital letter N here. And like I said, since it's an equation, since there's an equal to sign here, it means whatever is on the left hand side must be equal with that on the right hand side. But what do you notice? This number is in base 7 and this number is in base 9, which means they are different bases. So what we do here is convert each side to base 10. Convert this side to base 10 and this side to base 10. Why are we converting both sides to base 10? The reason is because all numbers are originally or initially counted in the denary system. The denary system is also known as the base 10 system, right? So any number that is not given in base 10 will be converted to base 10. So since this number is not in base 10 here, we have to convert it to the original number counting system. Are you getting what I'm saying? So we are converting this side to base 10, and we are converting this side as well to base 10. So we said when you're converting to base 10, multiply each of the digits that make up the number with the base written below it. So for this side now, I'm having 2 multiplies n, 2 multiplies 7 plus n multiplies 7 plus 4 multiplies 7. That's all for the left hand side. So I put powers of 10, 0, 1 and 2. That's equal to what I have on the right. Multiply each of the digits by the base written below it. So I'm having 1 times 9 plus 5 times 9 plus n times 9. So on the base, on top of the base, I'm putting powers of 10. So this is 0, 1 and 2. If you work with the exponent first, this side, 7 to the power 2 is 7 times 7, that's 49. And 49 times 2, if you multiply that, this is 18, that's 98, right? So that means this number here is 98 plus 7 to the power 1 is 7. 7 times n is 7n plus 7 to the power 0 is 1, and 1 times 4 is 4. Then 9 to the power 2 is 9 times 9, that's 81. And 81 times 1 is still 81. And then 9 to the power 1 is 9. 9 times 5 is 45. Plus 9 to the power 0 is 1, and 1 times n is n. So what do you notice? It has become a linear equation here. So what we do is collect like terms, right? So I'm going to take the variables to one side and take the whole numbers to the other side. That is the constant, the numbers that don't have letters here, I bring them to one side. So let me shift the numbers that has letter to the left hand side. That is all these numbers that have n. These numbers that have n, I'll put them this way, on this side. And numbers without n, I'll shift them to the other side of the equality sign. So here I'm having 7n. When this n crosses over the equality sign, it becomes a negative n. And on the other side, I'm having 81 plus 45. Then I'm carrying plus 98 over to become minus 98. And then plus 4. When I carry it over, I have a negative 4. So 7n minus n, that is 7 minus 1, that's giving me 6n. And that's equal to, when you add this together, if you first add this is going to give you 5 plus 1 is 6, and then 8 plus 4 is 12, that is 126. Then minus 98 minus 4, that's minus 102, right? All right, so when you have that, 6n is equal to, when you subtract this, 126 minus 102, this is giving you 4, this is 2, so you just have 24, right? So you have 24 at this side, so you have 24. And when you divide both sides by 6, you have that n is equal to 4. That is, the number that is going to be put here in place of n here is going to be 4. Alright, so question 2. For solution to question 2, the question said, if all numbers in the equation y over y plus 101 is equal to 11 over 10010 are in base 2, we are to solve for y. So the question itself says that y all over y plus 101, y plus 101 is equal to 11 all over 10010. 10010, and they told us that all of these digits are in base 2, right? Which means our answer as well is going to be a number in base 2. So from what we know about equations, we have to cross multiply. So when I cross multiply here, y is going to multiply this number here, so I'm having y multiplies 10010, and that's equal to 11 will multiply this, so I'm having 11 into y plus 101 rather, right? So 11 multiplies this, and then y multiplies that. So from here we can decide to expand the bracket, right? So we have y multiplies 10010, that's equal to 11 multiplies y gives us 11y, then plus 11 multiplies this in base 2. Yeah, I'm using this 11 to multiply, that is, this multiplies this, and this 11 to multiplies this man here. So 11 multiplies y to give us 11y, and then plus 11 multiplies 101, so in base 2. So if you have 101 in base 2 multiplied by 11 in base 2, so the number multiplication, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 1, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. If you add this, you have 1 1 1 1. That is, this multiplies that is giving us 1 1 1 1. Remember, all of them are said to be in base 2 from the question. We can decide to collect like terms. So if I should join this together, y multiplies this to give me 10010y. That is, I join this together, I multiply them to give me this, and that's equal to 11y plus 1111. So we collect like terms. 11y is coming to meet this man here, and this 11y is a positive a term, so when it comes here it becomes negative. So we have 10010y minus 11y, and that's equal to what's left here, 1 2 3 4. So if you subtract this in base 2, if you subtract this left hand side in base 2, you have 10010 minus 11. So we are subtracting 0 minus 1 is not possible. We have to borrow 1 from here and leave here with 0, put it here, that's 10, and 10 minus 1 in binary is 1, right? So we have 0 minus 1 is not still possible. Borrow 1 from here, put it here, that's a 10, remove it again, we have 1 left, put it here, remove it again, so we have 1 left here, right? So if you put it here is 10, and 10 minus 1 is 1. Here we just have 1, and here we have 1, right? That means this side here we have 1 1 1 1 y, right? That is this answer, and that's equal to what's on the other side, 1 1 1 y. So when you divide both sides by the coefficient of y, which is 1 1 1 1, this is cancelling this, so we have y to be equal to 1. 1 is in base 2. And then for question 3, we ask that if 124n is equal to 234 in base 5, we asked to find the value of n. Solution to number 3. They said 124 in base n is equal to 232 in base 5, 232 in base 5. We are asked to find the value. So the value of n here cannot be determined if we don't convert all the numbers to base 10. So remember, whenever you are given a question in this form, if it's an equation, your first task is to convert both sides to base 10. And to convert to base 10, you multiply each of the digits that make up the number with the base written just below it. So this number now is not in base 10. I have to convert this to base 10. This one too is not in base 10 too. I have to convert this one too to base 10. And for this part, to convert this to base 10, I have to multiply each of them here by what is written below it. I'm having 1 times n plus 2 times n plus 4 multiplied by n, and that's equal to 2 times, this is not in base 10 too, so I'm multiplying each of this by the base written below it. So 2 times 5 plus 3 times 5 plus 2 times 5. So for the right side, on top of the base, I'm putting powers of 10, so 0, 1 and 2, and on this side I'm having 0, 1 and 2, right? So if I start working with this man here, n to power 2 is n to power 2 times 1 is still n to power 2, plus n to power 1 is n times 2 is 2n, plus n to power 0 is 1 times 4 is 4, and that's equal to 5 to power 2 is 25 times 2 is 50, plus 5 to power 1 is 5, 5 times 3 is 15, plus 5 to power 0 is 1, and 1 times 2 is 2. So if we collect like terms here, this is n to power 2. It does not have any like term on the right, so I'm leaving this, plus 2n. So if I transpose this 4 here to the back of the other side of the inequality sign, I'm going to have 50 plus 15 plus 2, then minus 4, right? So we have that n squared plus 2n will be equal to, when you add 50 to 15, you have 65, and 65 plus 2, that's 67. So 67 minus 4, that's 63. So we have 63 right here, right? So it has become a quadratic equation rather. So I want to solve this using a factorization, right? I want to solve this, and to solve this using factorization, I have to bring this man inside here. So I bring 63 inside here. Okay, here is 63. If I bring it in, I will have n squared plus 2n. Then this comes in to become minus, because it's plus here, so when it comes in, it becomes minus 63 equals 0. Whenever a digit or whenever a number crosses the inequality sign, its sign must change, right? So you must know that every number has a sign in front of it. Every number has a sign in front of it. So this number now, this term here has a sign in front of it. So this term here has a plus sign. This 2 here, this 2n has a plus sign. This 63 has a negative sign. So whenever I'm carrying my 63 to the other side, I'm carrying together with the negative. So you see that 63 here was plus, right? It has a plus sign here. But when it came inside, it changed the sign to a negative sign there, right? So if you solve this using a factorization, actually, let's bring this down here. N squared plus 2n minus 63. So we're going to look for two numbers that are going to multiply to give us minus 63. So if I bring this down, I'm having minus 63n squared. That is, I'm multiplying the first term here and the last term here together, right? So n squared times minus 63 gave me minus 63n squared. So I'm going to look for two numbers that multiplies to give me 63. First of all, 1 times 63 gives me 63. 2 is not a factor. 3 times 21 gives me 63. Okay, 4 is not a factor, 5 is not a factor, 6 is not a factor, 7 times 9 gives me 63. So these are the factors of 63. These are the numbers that multiplies to give us 63, right? Now out of all of them, I want to pick one. I want to pick one pair out of these pairs, out of this pair, and this pair. I need one of them that I will add together or subtract to give me 2 here. Are you seeing that? I just need one pair. You know, I'm having 3 pairs here. This is a pair, this is a pair, this is a pair. So I need one of them in this place, that when I add the 2 of them together or subtract them, it's going to give me the middle number here. So I pick this one. 1 plus 63 is not going to give me 2, and 63 minus 1 is not going to give me 2 either, so I can't use this pair. Are you seeing that now? So if I use this pair, 3 plus 21, you know, I said I will either add them together or subtract them to give me the middle number here. So if I add these 2 together, 3 plus 21, that's 24, and if I subtract it, it's not giving me 2 either, so I can't use this pair. So if I try this pair, 7 plus 9, that's 16, and 9 minus 7, that's 2, right? So it means 9 minus 7 can give me 2 here, so I can use this pair. So I'm going to adopt this pair. I'm going to bring this pair in here, 9 and 7, or 7 and 9. So I'm using 7 and 9. Are you seeing that now? Because I know that when I add or subtract it, it's going to give me 2, right? Now what I want to do next is I will look for a way to multiply these numbers together, that I'm going to look for a way to multiply these 2 numbers together such that it's going to give me a negative at the end of the day. That is going to give me a negative 63. No, I said when you multiply those 2 numbers together, it's going to give you 63. But this 63 is a negative number, so I'm going to look for a way to do these 2 numbers. I'm going to look for a way to modify their sign such that if I should multiply them together, it's going to give me negative 63. And with that same sign modified, if I should add or subtract, it's still going to give me a positive 2. You just watch, right? If I say 9 minus 7, that's giving me 2, right? That is, this 7 owns the negative sign here, and this 9 has a plus sign. So I'm using, I put a negative in front of 7, right? So I'm just saying 9 times minus 7, that's giving me minus 63, right? And when I do 9 minus 7, that's giving me 2. Are you seeing that now? So it means I'm going to put a negative at the back of, in front of 7 rather. Are you getting what I'm saying now? So I'm putting a negative here, right? So that when I multiply minus 7 times 9, it's going to give me minus 63. And when I still add minus 7 plus 9, that's giving me a plus 2, just like the plus 2 that is in the middle here. Are you seeing what I'm doing? All right, let's get rid of this. So from here, what I want to do next is I want to replace the middle term. This middle term, I will replace it with these 2 entities here. But remember, what I'm replacing has an n. So this is going to have n, this is going to have n. So I'll copy the same equation, right? But when I get here, I will remove this 2n and I will replace it with minus 7 and plus 9, because there's a plus in front of 9 here. So this is going to give me n squared. I'm removing this now to put minus 7n plus 9n, then minus 63 as the equation, right? So equal to 0 rather. There's an equal to 0 here. From here, I can factorize this 2, and I factorize this 2 out. From here, I can see that n is common. Factor out n, you have n into n minus 7, and then plus, what's common here is 9 into n, plus times minus is minus, that's giving me 7, and that's equal to 0. So whatever in this bracket must be the same with whatever is here. So you see that n minus 7 is here, n minus 7 too is here. So I'm picking one of these 2 brackets. So pick one of these. You can either pick this one or this one because they're the same thing. So I'm picking n minus 7 from one of the 2, then I'm picking n plus 9. When I pick this one, out of this one, they are the same, so I pick one of them. So the next one I'm picking is n plus 9, and that's equal to 0. What it actually means is that it's either n minus 7 is equal to 0 or n plus 9 equal to 0, right? Because an equation. So when you finish simplifying this one, you have that n will be equal to, when minus 7 crosses, becomes plus 7, and then it implies that n will be equal to, when plus 9 crosses, becomes minus 9. So it means that the values we are getting, n is equal to 7 and n is equal to minus 9. But we know that since this n is a base, a base cannot be in a negative form, right? So we are picking the positive value of n. So we have that n is equal to 7. We can't pick 9 because a base cannot be, this is a base, and a base cannot be negative, right? This is a base too. This base is not negative. So this is a base, and it doesn't have to be in a negative form. So we pick the positive value of n, which is 7. And then for the next question, for question 4, we're asked to divide, how many ones are here? 1, 2, 3, 4, 5, 6, 7, 8. That is 8 of them in base 2 by 101 in base 2. So let's have the solution to number 4. So I'm having 1, 2, 3, 4, 5, 6, 7, 8. This number is in base 2. I'm about to divide it by 101 in base 2. Actually, there are two ways of going about this. You could either divide it straight, or you could convert each of them to base 10, right? But for the sake of this video, I would love to convert each of them to base 10, or I'll probably do the two methods, right? And we'll still arrive at the same answer. But please, if you are giving this in a theory exam, you will need to convert each of them to base 10, right? Don't use shortcut method. Convert each of them to base 10, because they will need to see your full workings. Are you getting what I'm saying? So for method 1 here, I can decide to divide this by this straight, right? For method 1, I'm not converting to base 10, I'm dividing straight in base 2. So I'm having 1, 2, 3, 4, 5, 6, 7, 8. That is the number, and I'm dividing it by 101. Don't forget that they are all in base 2. So now 101 cannot go in 1. 101 cannot be found in 11. 101 can be found in 111, because 111 is bigger than. Are you getting the concept? So what it simply means is that if this number here can go in any number here, it can only go once or 0, because we are dealing with base 2. So if I thought this number can divide here and divide these numbers here, it can only divide it once. And if it can't divide it, that's 0, right? Now 101 can go in 111. I'm dealing with this 3 first. How many times? It can go only once. So 101 times 1 is 101. I'm dealing with this 3 first. So when you subtract this one now, 1 minus 1 is 0. 1 minus 0 is 1. Are you seeing that now? So I bring down this next digit, this one here, this next digit, bring it down, join it together with it, it becomes 101. 101 in 101 is 1. 101 times 1 is 101. And when you subtract this man here, you have 0. Are you seeing that? So bring down the next digit, that is after the first 3, bring them down one by one. You see, I first picked the first 3. After that, I started picking them one by one. So now bring down this next digit. It becomes 0001, right? Now 101 in 1, this is just 1. 101 in 1 is not possible. And I said if it's not possible, it is going to go 0 times. So 101 times 0 is 0. And when you subtract, you have 1. Bring down the next digit. Join it. It becomes 11. 101 in 11 is not possible. It can't go. So we have a 0 there. And 101 times 0 is 0. When you subtract, you have 11. Bring down the next digit. You have 111 there. And 101 in 111 is how many times? It goes once. And 101 times 1 is 101. When you subtract this one, 1 minus 1 is 0. 1 minus 0 is 1. And 1 minus 1 is 0. So we just have 10 here, right? So bring down the last digit and you join it together there. You have 0101. So 101 in 10, because this is still 101, right? So 101, this 101 in this 101 is 1. So we have 1. So 101 times that 1 is 101. And when you subtract this, you have nothing left, right? So it means that this answer in base 2 is going to be, if you divide that in base 2, we are going to have 110011 110011 in base 2. This is the shortcut method, right? That is, if you see it in objective, you can use this method. But when you see it in theory, please convert each of them to base 10 using method 2 that I want to do now. So for method 2, we have to divide 1 2 3 4 5 6 7 8 in base 2 divided by 101 in base 2. We said we convert this to base 10. So 1 2 3 4 5 6 7 8 in base 2. We first convert this to a number in base 10. Sorry. We want to convert this to a number in base 10 first, right? So to convert this to a number in base 10, we say we multiply each of them by 2. So we have 1 times 2 plus 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 1 times 2. There must be 8. So 1 2 3 4 5 6 7 plus 1 times 2. There must be 8 of them, right? So we can add powers of 10 starting from the left hand side. So 0 1 2 3 4 5 6 7. So when you have 2 raised to power 7, I'm working with this exponent first. So 2 raised to power 7, that's giving me 128. And 128 times 1 is 128 plus 2 to power 6. That's 2 in 6 places. That's giving me 64. And 64 times 1 is 64 plus 2 to power 5 is 32 times 1 is 32 plus 2 to power 4 is 16 times 1 is 16 plus 2 to power 3 is 8. 8 times 1 is 8. Well, 2 to power 2 is 4 times 1 is 4. 2 to power 2 is 2 times 1 is 2 plus 2 to power 0 is 1 and 1 times 1 is 1. So when you add all those together, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, we have 255. So we have 255. This number is now in base 10. So I just converted this one first. I'm still going to convert this, then divide them together. So when I convert this one now, I'm having 101 in base 2. I'm converting this one 2 to a number in base 10. To do that, I multiply each of them by the 2 written below it. So 1 times 2 plus 0 times 2 plus 1 times 2. So this is 0, 1, and 2. So 2 to power 2 is 4 times 1 is 4. This is, since it's multiplied by 0, so everything here is 0. And this is 2 to power 1 is 2 times 2 to power 0 is 1 rather, times 1 is 1. So when you add all of those, you have 5 in base 10. So the question is just saying you are doing 255 in base 10 divided by 5 in base 10. 255 divided by 5, that's 51 in base 10 from the question, right? Now this answer, we have to convert it to base 2, right? So if we divide, we're just going to divide it by 2. Since it's already in base 10, we divide it by 2, and of course there's going to be remainders. So 2 goes in 51, that's 25, right? And 2 times 25 is 50. What will you add to 50 to make 51? That's 1. So we have remainder 1. 2 goes there is 12, right? 12 remainder 1. because 2 times 12 is 24 plus 1 is 25. 2 goes in 12 is 6, remainder 0. 2 goes in 6 is 3, remainder 0. 2 goes in 3 is 1, remainder 1. And of course, you know 2 can go in 1, so we stop there. So we pick our values from here and we go upward. So it means that our answer is going to be 1 1 0 0 1 1 in base 2, which is still the same thing we got here. 1 1 0 0 1 1 in base 2. So for the next question, that is question 5, we are asked to convert 11.011 question 5 11.011 in base 2. We are asked to convert it to a number in base 10, right? So we did this last week. We said we'll multiply each of them by the base if we're converting to base 10, right? So for the whole number part here, I'm having 1 times 2 plus 1 times 2 plus, for the decimal part, I'm having a bracket to secure it. So 0 times 2 plus 1 times 2 plus 1 times 2. So on top of the whole numbers, I'm having a powers of 10, that is 0 and 1. Then for this part, there's no 0. It starts from a negative 1, negative 2, and a negative 3. So 2 to 1, 2 to power 1 is 2 times 1 is 2, plus 2 to power 0 is 1, 1 times 1 is 1, plus, since this is multiplied by 0 here, everything here is 0, right? Plus, this is 1, this one multiplied by, this minus here is the inverse of 2 raised to 2, plus this one multiplied by, the minus there is the inverse of 2 raised to power 3. So when you add this whole number part, you have 3 plus, this 0 is gone, so 0 plus all of this is still the same thing. So we just have 1 over 4, cos 2 to the power 2 is 4. So we have 4 plus 1 times 1 is 1 over 2 to the power 3 is giving us 8 there. So this is a fraction, unlike fraction. But I take the LCM of these two numbers, it's giving me 8, right? So 4 in 8 is 2. 2 times 1 is 2. And then 8 in 8 is 1. And 1 times 1 is 1. Remember, this is the decimal number part. So this is 3 plus, this is 3 over 8. And your answer is supposed to be, your answer could be in this form, that is 3 whole number, 3 over 8. Or it could be in mixed, in proper fraction rather. That is 8 times 3 is 24, plus 3 is 27 over 8. Or it could also be in decimal, right? So if you check your options, if you don't see this one there, you don't see this one there, definitely you will meet decimal as your answer. So we convert this to decimal now. If you punch 27 divided by 8 on your calculator, you have 3.375. This is the answer in base 10. And for the next question, for solution 6, we're asked to find the value of x for which 312 in base 4 plus 52 in base x is equal to 96 in base 10. So let's take it step by step. So we have 312 in base 4, 312, solution to question 6. 312 in base 4 plus 52 in base x, if I'm not mistaken, plus 52 in base x is equal to 96 in base 10, is equal to 96 in base 10. Remember I told you something, that if the question is not in base 10, your first assignment is to convert it to base 10. That's the first step. So this one is not in base 10, convert this to base 10. This one too is not in base 10, is in base x, convert to base 10. This is already in base 10, so no need of converting this, it's already in base 10. So this part now will be 3 multiplied by 4 plus 1 multiplied by 4 plus 2 multiplied by 4. I'm done for this part. Then this plus, this is it here. So I can secure this one. 0, 1, 2. That's for this part. Then for this 52, that's a 5 times x, multiply each of them by the base, plus a 2 times x. So I have 0 and 1, and that's equal. This is already in base 10, so I'm not converting that, so I'm having 96. So I work on this part. This is 4 to the power 2, giving me 16 times 3. That's 48, plus 4 to the power 1 is 4 times 1 is 4, plus 4 to the power 0 is 1 times 2 is 2. That's for this part. Plus x to the power 1 is x times 5 is 5x, and then plus x to the power 0 is 1, and 1 times 2 is 2, and that's equal to 96. So I'm having, if I add all this part together, I'm having 48 plus 4 plus 2, that's 54. So everything here is 54. Then plus, I'm having 5x plus 2, that is this part, is equal to 96, right? So if I collect like terms here, I'm having 5x, 54 plus 2 is 56, right? If I add this 52 plus this together, and that's equal to 96. So 5x will be equal to 96. This 56 has a plus sign. When it comes over here, it becomes negative 56. And when you subtract that, 96 minus 56, that's giving you 40. And when you divide both sides by 5, you have that the value of x is 8. That is, this number, that is this question, is in base 8. So if it's in base 4 and this in base 8, when you add them together, it should give you 96 in base 10. And for the final question for today, we are asked that if 1, 2, 3 in base y is equal to 83 in base 10, obtain an equation in y. Hence, find the value of y. It is very much simple. 1, 2, 3 in base y. 1, 2, 3. Solution to question 7. 1, 2, 3 in base y is equal to 83 in base 10 is equal to 83 in base 10. This number is already in base 10, so we are not working on that. So we just work on this man here and convert this to base 10. So having 1 multiplies y plus 2 multiplies y plus 3 multiplies y, and that's equal to, this is already in base 10, so I'm leaving it like that. So I'm having 0, 1 and 2. So y to power 2 to power 2 times 1 is still y to power 2. Y to power 1 is y times 2 is 2y, plus y to power 0 is 1, and 1 times 3 is 3, and that's equal to 83. So when you have this, you have y squared plus 2y equals 83. Transpose the plus 3, becomes minus. So we have y squared plus 2y equals 80 here. So it has become quadratic in nature. So I have to use any of the method for solving quadratic equation. So I would love to employ the factorization method here. So same thing I would do, bring this 80 inside here. So I have y squared plus 2y minus 80 equals 0. This is the equation in y, right? We have to obtain an equation in y, which is this, then solve to get the value of y. So if y is a base, y must not be negative. So y here is a base, and a base is not always in negative. So we are obtaining two values, right? So let's continue. So we have that. All right. So from here, I want to solve using the factorization method, and to do that, I'll have to bring this equation to the next page. So y squared plus 2y minus 80 equals 0. So I'm bringing the first term here and the last term here, and I'm multiplying them together to give me minus 80y squared. So the next thing I want to look for is to look for two numbers that multiply to give me 80. That is the factors of 80. So first one is 1 times 80 is 80. 2 times 40 is 80. 3 is not a factor. 4 times 20 is 80. 5 is a factor, so 5 times 16, right? 5 times 16. Okay, 6 is not a factor. 7 is not a factor. 8 is a factor. 8 times 10 is 80. Okay, I think I can get. Let's see. So if I add this pair, I'm having 1, 2, 3, 4, 5. I'm having 5 pairs here. So which of these pairs we add up or subtract to give me 2? So 1 plus 80 is not 2. 80 minus 1 is not 2. 2 plus 40 is not 2. 40 minus 2 is not 2. 4 plus 20 is not 2. 20 minus 4 is not 2. 5 plus 16 is not 2. 16 minus 5 is not 2 as well. So 8 plus 10 is not 2. 10 minus 8 is 2. Are you seeing that now? So this is giving me a green light, so I can use this, right? So I'm going to get rid of the remaining. So I'm using 8 and 10. So here I'm using 8 and 10, right? So the next thing I want to do is to modify this 8 and 10 in such a way that it's going to give me negative when I multiply, and when I add it's going to give me a positive. So if I have minus 8 times 10, that's minus 80. I want to have minus 8 plus 10, that's giving me a 2. So I'm adding negative in front of 8, right? Because when I multiply with a negative in front of 8, I'm having 80 here. And when I have a negative in front of 8 and I add them, I'm having a plus 2. So I'm adding a negative in front of 8, just that. So and then what I want to replace as a y, so I'm going, this is going to have y, this is going to have y as well. So let me get rid of this. So from here, if I should continue working further, I want to replace the middle number here with these terms here. So when I do that, I have y squared. I want to remove this now and replace this one with this 2. So I'm having minus 8y, then plus 10y, and that's equal to, sorry, minus 80, and that's equal to 0. So I replace this 2y, just the 2y alone, with this 2. So in place of this 2y, I put this 2 there. Then my minus 80 is still there, and my equal to 0 is still there. So I can group these two and factorize the two brackets. So from the first bracket, y is common. I have y into y minus 8, and then plus. From here too, I can see that 10 is common. 10 into y minus 8, and that's equal to 0. So what's in the bracket? This bracket is the same with this, so I can pick one of these, y minus 8, and then y plus 10. This is equal to 0. So what it means is that y minus 8 is equal to 0, or y plus 10 is equal to 0. That is, either this is equal to 0 or this is equal to 0. So it implies that this one, if you carry 8 over, you have y is equal to 8, that is plus 8. And then it implies that y will be equal to, when you transpose this, you have minus 10. And y is a base. A base cannot be in a negative form, so we can't use this. So our value is y equals 8. Thank you for watching, and see you on the next one.